All right, so this is kind of what your table looked like from the lab yesterday, right? You have like some light data and some dark data. You had total stomata, you had closed, and you had open. Does anybody have their lab on them from yesterday? Yes. Can you read me for the light data how many were? Actually, before we do that, let's do this. I'm going to say field 1, because we took like 6 measurements, right? You took 3 measurements, and then you got data from your neighbor for the other 3. Yes. So I'm going to say field 1. I'm going to go here, and then I'm going to make the black X turn into a, or I'm going to make the white X turn into a black X, and I'm just going to drag down until I have 6 fields, just like magic. Do that one more time. All I did is I just typed in field 1, and then Excel knows if you go to the bottom right-hand corner and make the white X turn into a black X, it knows, oh, you want more of these, and it iterates those numbers. Counts them right up. Courtney, can you read some data to me? Yep. No, closed. Closed is straight down the list.
23, 21, 23, 25, 22.
And then open.
Open was 84, 60, 102, 96, 81, and 65.
65. Perfect. So I know you've already added these up. I know you have these numbers already, but I'm going to make Excel do it for me so we get a little bit of practice with this. So I'm going to write another sum function. Remember, sum just adds things together. So I'm going to go over here and hit equals sum, S-U-M, open parentheses. Now I want the total stomata from field 1, so I just want to add this number and that number together, right? So I'm going to type in equals sum, and then I want C3 through D3. This is C3, this is D3, I want to add those up. If you type that in and hit return, it should do it for you. The other way you can do it is to type in equals sum, open parentheses, and then just go and select the data that you want. Another way that you can do this is to write it once, and then go to the bottom right-hand corner and drag it down, and it will copy the formula for you. Another way that you can do this is to copy these 3 cells and paste them down, if I could do it correctly, and paste them down, and it will get the correct formulas and just do them correctly for you. Okay, bunch of different ways we can do this. Let me start over though, just so we're all on the same page. All I want to do is add up these data. So I go total stomata, I type in equals sum, I'm going to say C3 through D3. I'm going to close the parentheses, and it gives me the total there. I'm going to type in equals sum, and I want these 2 data points, so I'm going to select them and hit return, it gives them to me there. C5 through D5, C6 through D6. Oh, it doesn't like that. Oh, it doesn't like that, even worse, okay. Or you can pick a cell that already has the formula in it, go to the bottom right-hand corner, drag it down, it'll add those things up. Good? Can you read me your dark data too? We'll just be consistent. Just read the closed all the way down. 101, 130, 26, 56. Okay, and open. 8, 0. Okay.
14,
Interesting. Okay. So you can do another cool thing. You can just select all this here and paste it in, and look, everything is correct. Excel is magic. Or I'll do it long form. I'm going to type in field 1 here. I'm going to click on that, and then I'm going to go to the bottom right-hand corner and drag it down until I have 6, because we counted 6 in the light, we counted 6 in the dark. Now I want to know the total stomata in each of these, so I'm going to go here, type in equals sum, open parentheses, grab these data, hit return. Equals sum, grab these data, hit return, equals sum. I could also do it like this. I could say C14 through D14. If I want to type it in by hand. C15 through D15. So if I'm like going too fast or whatever, please slow me down. Okay? If you're comfortable with it, that's okay, but if I need to chill out, you can tell me. So I'm going to go to here, and I'm just going to drag this formula down because I'm tired of typing stuff. And this tells us our total number of stomata, how many open, how many enclosed, in all of our fields, right? So then we've got this other issue over here, which is this percent open thing going on. So let me talk about percentages. How many people are in here today? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 15 people, 16 people, because I'm here. How many of us are wearing sweaters or jackets? That's like a flannel, but we'll count it. 1, 2, 3. Martina, is that like a long shirt or is that a sweater? So long sleeve. Okay, 1, 2, 3, 4, 5. That's not really a sweater. Oh, that's like a cardigan. We'll say 6, 7, 8, 9, 10, 11, 12, 13. So how many, what was our total number of people? Our total was 16 people who are warm. So what is our percentage of people who are warm? Sure, how'd you get that number? 13 out of 16. A bunch of us are warm. Okay, a lot of us. So what number was that? 80, 81. Okay, so now we're going to look at these data. Of this first field, what is our percentage of open stomata? Same exact question, but just with open stomata. It works the same way. How many of these are open? Like literally 84. But what percentage is that of the total? How'd you get that? 84 out of 107. I don't feel like doing that by hand. I'm going to make Excel do it for me. So our percent open here, what numbers are we going to use? 84 and 107. So my 84 lives in D3, so I'm going to specify that by telling it equals D3. Division works slightly differently in Excel. I don't know why. Excel is magic. It's also dumb. So I'm going to say equals D3. There isn't a special like function thing for adding. You just hit a slash. We're going to say D3 divided by B3. For me, it's B. I'm going to hit return, and that's going to give us this number, 0.785 and some change. Let me ask you this now. How do you prefer to look at decimals? Do people prefer, I mean, how do you prefer to look at percentages? Do you like it as a decimal, or do you want it as a whole number? A whole number, we can deal with that. So here's what we're going to do. We're going to go up to our function, D3 divided by B3, and you actually, for this, you should click up here to this formula bar thing. I mean, you can also just, we could also just erase it. We'll do that. That's fine. So I'm going to hit equals again because we need to start over. And now I'm going to put a parentheses, an open parentheses. Equals B3, or I'm sorry, D3 slash B3. And again, it's specifying, it's showing you, okay, you're taking this number and you're dividing it by that number. After you have that part of the function written down, you're going to close those parentheses and hit an asterisk 100. The asterisk in Excel means multiply. This number divided by that number times 100. And this should give us a whole number version, 78%. There are ways that you can tell Excel to do this kind of automatically. I prefer this function, or I prefer doing it this way for a handful of reasons. But if you want to figure out how Excel can specify that for you without multiplying by 100, that's cool. So D3 divided by B3 times 100. Actually, it's like this. The reason we do this is because Excel is magic, but it's also dumb, and it doesn't really know the order of operations like as well as we do. All right, so we can continue writing this function. We can do this again and again. This would be equals D4 divided by B4 times 100. Add some parentheses. Oh, it did it right. That's surprising. I'm going to put parentheses anyway. Or we can just kind of do it the smart way and click on one of these cells, go to the bottom right-hand corner, and just drag it down. There you go. Pretty good. And we're going to do the same thing for our dark data. Now, you have the option of rewriting those functions, or you can just kind of select these data here and copy them and paste them in, and you'll notice everything is pretty coherent, which is awesome. But for the interest of you seeing it again, I'm gonna do it again. So I'm gonna go down here to my %open for my dark field number 1. Down here, and I'm gonna divide this number by that number. So equals D12 divided by B12 times 100, and I forgot my parentheses. Equals D13 divided by B13 times 100. Equals D14 divided by B14. And I forgot to times it by 100. Or again, you can click on one of the cells that already has the function in it, go to the bottom right-hand corner, click and drag it down. Awesome. It's very apparent that 2 people collected these data. Very, very apparent. And that's great, because that's kind of the point of the next thing that we're going to do. So let's make some summary data. I'm going to say light. I'm going to say dark. I'm going to say average. Move this over here really fast. So what is the average that we're going to take for our light data? What average would we like to know there? What average are we interested in for those? Yeah, you don't care about the number of open stomata necessarily because it's kind of going to depend on what part of the leaf you were looking at. So we're going to write a function equals average, open parentheses, and then you're going to select all of this data for the light condition. Everybody on board? See what I just did there? Here, I'll do it again for dark. Equals average, open parentheses. We're going to select all that stuff. You could also do it like this. You could say, I want E12 through E17. The colon kind of means through in Excel. So E12 colon E17 specifies all of this data here. Great. So we have our averages, we have our light, we have our dark. There is one slight problem though. And that is, one of these data points says like 7.3%, and another one says like 35%. What's up with that? Why do you suppose it is this way? Yes, but you have some data points that are quite low and some data points that are quite high. Not necessarily. It's just that two people collected these data, right? It's very obvious, very, very obvious. There was a disagreement here that was never settled about what an open stomata is and what a closed stomata is. That's not a big deal. I don't care about that. It's just that this average is misleading. This average over here is misleading. Who is the guy that, like, trying to think of a really, really rich person? I used that one this morning, but yeah, well, Bill Gates. That's fine. We'll say Bill Gates. I don't know how much money Melinda Gates makes, but what do you think the average household income? Let's say Bill Gates has 2 kids. So there's 4 people living in Bill Gates' house. What do you think the average household income of Bill Gates' house is? Like $1 billion a year? How much do you think his kids make? Probably somewhere below that, 120,000. I don't know what the number is. I'm not trying to disparage Bill Gates or his kids, but it's lower than Bill Gates, right? Averages are misleading. Averages are misleading. The average American has 1 fallopian tube. Right? If you just told me the average of these things is 21, yes, that's true, but there's something missing here, right? Some of these data were lower, some of these data were higher. So the way that we can encapsulate that is by using this thing called a standard deviation. So the way we can encapsulate these differences is using this standard deviation. We did this before, but I'm going to put that here. I'm going to say standard dev. So I'm going to say equals stdev dot s for our sample standard deviation. And I'm going to do an open parentheses, and I'm going to select all of these data. And that gives you a value of about 6 for these light data. Gives you a value of about 6. Again, I'm never going to ask you for the formulae for these things. What I'm saying is that standard deviation captures differences between individual data points and the mean. We're going to do the same thing for the dark, equals stdev dot s, and we're going to select all of our dark data. Big number. You'll notice that the standard deviation for the dark is significantly higher than the standard deviation for the light. Maybe I'll give you a slightly more tangible example of this. So over here, I'm going to say, I don't know what kind of data we're going to be talking about. How about, I don't know, average tree height? It doesn't matter. But I'm going to make up some numbers here. You don't have to do this. I'm just kind of showing you. What do you suppose the standard deviation of this data set? We have all these trees that we measured behind it. Are these numbers really close to each other? Are they really far from each other? Let's do it like this. We'll say average tree heights. This will be like area 1. This will be like area 2. It doesn't really matter. This is just an example, but so what do you think about this data set? What is the standard deviation of this data set? It's going to be low, it's going to be high. What are all of our numbers doing? Are they all in the same area? I mean, compared to this one, not even close, right? Let's just figure it out. Let's take the standard deviation of each of these. Standard deviation of this one is 15. The standard deviation of this one, you don't need to do this right now, by the way. Standard deviation of this one is 1. Okay. Standard deviations help you to figure out that there are big variations in the data set. Average does not tell the whole story. Median sometimes tells a good story, but it doesn't always tell the whole story, okay? So again, I'm not going to ask you for like the formula of any of these things. What I will ask you is kind of like, what does a standard deviation mean? Why do we need one? All right, and since I was going to have you actually graph standard deviations, because very often when you're looking at scientific publications, they won't always use standard deviations, but they'll use some metric to show you how the data vary. So they'll have some graph, something like this, and they'll have these things here called error bars. These error bars are sometimes representing standard deviations. So, okay, let's think about it like this. What if I showed you this graph, and this was a graph of percent open stomata? Which of these would you expect to be the light, and which would you expect to be the dark? This is light. This is dark. This is percent open stomata. Does this tell a story that looks correct to you based on what we talked about yesterday? Maybe correct-ish anyway. Light has a bunch of open stomata, dark has a bunch of not open stomata. What if it looked like this? What story are we telling now? There's no real difference between these two averages because your standard deviations are massive. There's something wrong here, or there's no story. There's nothing to be told. There's nothing going on. All right. So let's generate a graph really quick of just these data points. I'm going to select average and light and dark. Actually, let's just do light and dark. I'm going to go up to insert. Let's try to do a clustered column. Perfect. That's what we want. It's a clustered column. Does this data, does this make sense? Does the story we're trying to tell here make some sense? Why do plants have open stomata? No.
Because of photosynthesis machine, because of the light?
That you're saying correct things, you're missing the bigger picture.
Okay.
Plants have stomata, and stomata are open so that plants can exchange gases with the environment, right? Stomata are for gas exchange. If a plant isn't undergoing photosynthesis, does it need to exchange gas? You guys are falling asleep, so yes. If a plant is undergoing photosynthesis, it needs to exchange gas. If it's not undergoing photosynthesis, it does not need to exchange gas. So the deal with this lab today, I'm going to have you do a quick lab write-up. I will be sending out instructions to you probably tonight about how to do this. Okay, it's going to involve a graph that looks like this, and it's going to involve reporting your standard deviations. Normally, I would have you actually put them on the graph, but since we have such a variable group of Excel software available to us, I'm just going to have you report it. Okay, so you're going to make a graph like this one. If you've made a graph with your data on these computers, I recommend emailing it to yourself. If you haven't made one yet, it's not a big deal. If you didn't follow along totally, I recorded most of this second part of the session where I was talking about these data. I'm going to post this online so you'll be able to check it out again. I hope I didn't swear. So yeah, if you have stuff that you would like to chat with me about right now, there's 10 minutes left in lab. If you're feeling good about this stuff, You can get out of here, put your computer back nicely, please, put the cords back where they go. I will see you guys tomorrow. Thanks, got probably talk for 2 I don't know. Did you give me a paper copy?
Yes.
Then you're fine. No worries. Yeah, it's just because of the way that's like, I'm going to take care of all that. So you should be good.